Now see here, based on this table here, we have octet format. Octet format means like this one here. We have n dot h dot h here. Octet means 8 bits. Network octet means we have 8 bits here, and the values of 8 bits is ones. The values of 8 bits is ones here. For example, network octet, okay, is identified like this, like your 1, 2, 3, 4, 5, 6, 7, 8. Then here H here. What is H means? Host here. Octet means 8 bits. Host means H is equal to host with repeated bit value 0 here. Host octet means we have 1, 2, 3, 4, 5, 6, 7, 8. So the previous one is network here. This is your network here. And this is your host here. Again, for one more host, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. And this is say the second host, and this is your second host, and the third host here. If you have all ones here, the value is 255. Its value is 255.0.0.0.0 here. This value is 255 here. So 255.0.0.0.0 here. From this octet format, actually this value is calculated. It's called as subnet mask here. Called as subnet mask. The subnet mask of class C, sorry, the subnet mask of class A. The subnet mask of class A is 255.0.0.0. Now, based on the same calculations, if you do for the second one here, the subnet mask of your class B will be 255.255.0.0. And subnet mask of class C here, the subnet mask of class C will be, it's like this, 255.255.255.0. 255.0. When any address is specified, for example 192.168.1.1, when any address is specified here and they ask you what the class of IP address here, only see the first number 192 and check it out into which range does it falls into. 192, the range of address is class C. So the class of IP address is class C here. The class of IP address is class C here, and whose subnet mask is 255.255.255.0. You can see it here for class C. What the class C subnet mask is 255.255.255.0. The next here, when you go for the second example here, like see here 169.254.0.1, 0.1. The class of IP address, see here, this 169 falls into this range here, B here. The class of address is class B, and what the subnet mask will be 255.255.0.0. Now when you go for this first example here, for example here 10.0.0.1 here. Now when you go for this one, this is class A address here. This class A address here, the subnet mask is 255.0.0.0.0. Okay, so 10 falls into this range here, 0 to 127. So if someone asks you to what the, when you give an address and asks you what the class of IP address, you only see the first number, that is 192. That is 192. And see here, with the help of the range, we can identify what the class of IP address is here is. And to calculate the range here, we use this priority bit. We use this priority bit here. And all this classification comes under IP version 4. Right? All this classification comes under IP version 4 here. It's IP version 4. Now, for the class A, B, and C, we have octet format. We don't have octet format for class D and E here. And the subnet mask is calculated from this octet format. Now, what the purpose of this octet format is? Why do you require this octet format? What the purpose of octet format, and why do you require this octet format? Now see here, like for example, I have few systems like here, like a system your system A, your system B, and system C. Where my system A address is here is like 192.168.1.1. My system B address is 192.168.2.2. My system C IP address is 192.168.3.3. Will system A communicate with system B and system B communicate with system C? Means the thing is all the systems can communicate with each other only when they are same network here. You can see it here. Note, all the systems, can communicate with each other only when they are in same network. Only when they're in same network. And to identify same network here. The next, to identify whether they are in same network or not, here, mask subnet mask is used. All the systems can communicate with each other only when they're in same network here. To identify whether they're in same network or not here, what is used? Subnet mask is used. Okay. Now you can see it here. When you go for this address here, the class of address is class. Let me write over here. Like a octet format is n.n.n.h. In the same way here, n.n.n.h here. Like your n.n.n.n.h here. Now here, where n stands for network, H stands for port here. If all the network hops are equal between two different system address, two different system address here, then we say that they're in same network. For example, see, let us compare the first network 192, 192, yes, they are equal. When you compare the second network here 168, 168 equal. Third one 1, 2, they're not equal. So the first two networks are equal. The third network update is not equal here. Then what do you mean by this? They are not in same network. They're not in same network. Then they cannot communicate with each other here. All the systems can communicate with each other only when they're in same network. But in this condition, they are not in same network. What do you mean by this? They cannot communicate with each other. Suppose if I change this value to 1.2, now you can see 192.168.1 and 192.168.1 here, both are in same network. They can communicate with each other, right? In a similar way here, in system C, if I modify this to 1.3, now what happens? All the systems can communicate with each other. All the systems can communicate with each other only when they're in the same network. Whether the same network or not to identify, then the subnet mask is used. Okay. Then see here, second example, A, and like A, this is your system A, then system B and system C. Assume the system A address is 169.254.0.1. The system B address is 169.254. like a 20.1, and the system C address is 192.168.3.3. Oh, 1 minute. Let me like 169.254. Now see here, I've given three addresses here. Will these three addresses communicate with each other or not? Can a PCA communicate with PCB? The second case, can PCB communicate with PCC? Under one condition, whether they're in same network or not. To identify whether the same network or not here, first we need to identify the class of IP address. So 169, see here, falls into this range B. What the octet format is? n.n.n.h. n.n.n.h here. Now from this one here, you can see it here. Like what the network is, it's like this. n.n.h.h. H. Now here it's n.n.h.h here. Then here n.n.h.h. Now see, we have only two network octets. In class C, we have three network octets. All three network octets have to be equal here. But in class B address here, we have only two network octets, means only the first two network octets have to be verified. Okay. Now see here, 169, first network, okay. 169, they are equal. Second, 2T4 and 2T4, they are equal. When you compare between B and C, 169 is equal, 1224 is equal, means all the systems can communicate with each other. Okay, why? Because the class B address, see here, in class B address, only the first two octates are verified to check whether they are in same network or not. Now let us see the third example here, like a system A, B, and then C. Let's try that here. 10.0.0.1, like a 10.200.200.3, then 11.2.0.2.1. When your system A and B communicate means, first check the IP address here. The class of IP address is class A. So what octet format is? The octet format is like this, n.h.h.h here. And for class B, what octet format is? Sorry, the second class is one n.h.h.h here. And for the third system C here, n.h.h.h here. Only first network has to be verified. Between A and B here, you can see 10 and 10. They are same. What do you mean by this? They can communicate with each other. But when you verify between B and C, in B we have 10, but in C we have 11. What do you mean by this? They cannot communicate with each other. So A and B can communicate with each other. B and C cannot communicate with each other. Why? Because B and C falls into different network here. In the above example, like your A and B can communicate with each other, but B and C cannot communicate with each because they are in different network. The main point here. So why do you require this subnet mask? This is one of the example here. Why do you require subnet mask here? Is mainly to categorize and to identify whether systems are in same network or not. Then we have one more very important example of the subnet mask here, right? See here, purpose of subnet mask, okay, which is purpose of a subnet mask, which is derived from octet format. Okay, what the purpose is like this. Now for example, see here, sys1 plus sys2. Interconnection of two or more devices is called network. For example, this is network here which consists of two PCs. The next, sys1 plus your sys2 plus your sys3 plus sys4. So we consist of four PCs. In first network we have two PCs. In second network we have four PCs. In a similar way here, sys1 plus your sys2 plus sys3, like this, we have three PCs, right? In the third network we have three PCs. In the first network, assume that we have two systems here. In second network we have four systems here, and in third network we have three systems here. So where these PCs are also called as hosts here, we can simply say that we have two hosts. And here how many hosts are there? Like we have four hosts. And here in third example again, how many hosts do you have? We have three hosts here. So we have like the three different networks here. Network 1 we have two hosts. Network 2 we have four hosts. In third network we have three hosts here. Like this, how many networks can you create in class A? We have a network here. Like this, how many networks can you create in class A? And per one network, how many host pieces can you connect? You can see based on this example which I shown you here. Based on the example which I shown you here, I've shown you three networks. And in network 1, I shown you 2 hosts. In network 2, I have 4 hosts. And in network 3, I have 3 hosts here. Like this, how many networks can you create in class A? And per one network, how many systems can you connect? How many hosts can you connect here? If you want to do that calculation, we use the subnet mask. See, the octet format is used to uh, calculate the number of uh, networks that can be created in a class and per one network how many host pieces can be connected can be connected. Okay, let us do this one. Like for example here, if you want to do these calculations here, to do the above calculations to do the above uh, calculations the following formulas are used. So first one, to calculate the number of networks to calculate number of networks here, that is 2 to the power of 2 to the power of n minus p. 2 to the power of, you can write here 2 to the 2 to the uh, power of n minus p. Both n and p are at the powers. Both n and p are at the powers here. The next second point here, to calculate the number of hosts, the formula is 2 to the power of h minus 2. 2 to the power of h minus 2. Now here, the minus 2 is at the base, only h is at the power. Minus 2 is at the base here, h is at the power here. Okay, you can see it here. H is power and minus 2 is at base. Right. Here, where n is equal to number of priority bits, priority bits, and sorry, where p is equal to number of priority bits. Okay, and n is equal to number of network bits, and h is equal to the number of host bits. N is equal to number of network bits, h is equal to number of host bits, p is equal to number of priority bits here. Now we need to write these values here for class uh, okay. Then first one is like your number of network bits, the next number of host bits, the next number of priority bits, priority bits. Okay, let us get the table there. Now see this table. For class A, what the priority bit is? 0. Whether it's 0 or 1, but it's one of the bit here. It's one of the bit here. The number of priority bit is 1. And for class B, the priority bit is 10, means the number of priority bits is 2. And for class C, the number of priority bits is 3. So in class A, what number of priority bits is? In class A, the number of priority bits is 1. In class B, the number of priority bits is 2. And in class C, the number of priority bits is 3. Now when you go for this octet format here, in class A, where N is called network and H is called as host here. Network octet means one octet consists of 8 bits. So what the value of N is? 8 here. And we have 3 host octets. One octet consists of 8 bits here. So 8 threes are how much? 24. Number of network bits is 8. Number of host bits is 24. Now in this class B here, the number of network bits is 16, 8 plus 8. And the number of host bits is 16, 8 plus 8. And in class C, the number of network bits is 24 and what the host bits is 8. Based on this, I will write the values C here. Like for example, the first one is for class A. So when you go for the class A, the number of network bits is, how many network bits we have? 8 network bits. The number of host bits is like 24. And the number of priority bits is whether 0 or 1, 1 value. And for class B, so when you go for class B here, the number of network bits is 16, the number of host bits is 16, the number of priority bits is 2. And for class C here, and for class C, the number of network bits is 24, the number of host bits is 8, and the number of priority bits is 3. Now simply substitute these values in those formulas. Substitute these values in their formulas here. So you can see, let us do the calculations here. See calculation for class A, right? So first one, the number of your network, the number of network bits, sorry, the number of networks. What the formula is? 2 to the power of like n minus p. Okay, that is 2 to the power of, what the value of n here is? To the power of, what the value of n in your class A? The value of n, number of network bits is 8, right? The value of it is 8 here, minus, and what the number of priority bits is? The number of priority bit is 1. 2 to the power of 8 minus 1. So 2 to the power of 8 minus 1 is equal to like a 2 to the power of 7 is 2 to the power of 7. And what the value of 2 to the power of 7 is? 128. Okay, so in class A, how many networks can you create here? In class A, the number of networks you can create is 128. 128 here. The number of networks that can you create in class is 128. The next, second formula here, to calculate the number of hosts here. When you go for the number of hosts here, you can see what the formula is: 2 to the power of h minus 2. That is 2 to the power of 24 minus 2. So when you go for 2 to the power of 24 here, 1 6 777 216 minus 2. So the value is 1 6 777 214. This many number of hosts. Means you can see here these are number of hosts here. Like this. In the previous example here, I said that in network 1 are connected only 2 hosts. But how many networks can you create in class A? In class A, we can create 128 networks. In class A, we can create 128 networks. And per one network, we can create 16777 hosts here. This many number of hosts can be connected. Right? This many number of hosts can be connected. Right. Now here when you go for this class A, we have 128 networks, but we cannot use 128 networks here. See one thing, note, in class A, the number of networks which we can create is 128, but out of which we can use only 126 because we cannot use the first and the last one. We cannot use because we cannot use yes, the first and the last one. That is like 0.0.0.0, that is 0.0.0.0, which is called as undefined address. Then second one is 127.0.0.0, right, which is called as a loop back address. 0.0.0 is called as undefined address here, whereas 127.0.0.0 is called as loop back address. So we cannot use the first and the last address. The first one is called as undefined address, second is called as last. So how many are valid networks are? The valid networks are 128. The next here, note 2. While calculating the number of hosts, we are subtracting with -2 because we cannot use the first and the last host. Okay, we cannot use the first and last host here. The first one is called as network ID, and the last one is called as broadcast ID. The first one is called as network ID and the last one is called as broadcast. So in class A we got 126 networks, but we cannot use the first and the last one, right? The first one is called as undefined address, the last one is called as the loopback address. While calculating number of hosts also, we cannot use the first and the last one. The first one is called network ID and the last one is called as broadcast ID. We'll be discussing more about this network and last broadcast ID here when we discuss about class C calculations. Now let us see here, like calculation for class B. Okay, when you go for calculation for class B here, the first one, the number of networks. So what the number of networks is, the formula is 2 to the power of like n minus p, right? That is 2 to the power of your 16 minus 2, right? That is 2 to the power 2, that is 2 to the power of 14. So 2 to the power of 14 is equal to 16,384 networks. So in class C, how many networks can you create? We can create 16,384 networks. 16,384 networks here. And for one network, how many hosts can you connect here? Let us do the calculation here. The second one is the number of hosts. The number of hosts is like a 2 to the power of like your h minus 2. So what the value of 2 to the power of h here? Here 2 to the power of 16 minus 2. Okay, that is 65,536 minus 2. So 65,534 hosts are there. In class C, for one network, altogether we can get 128 networks, but valid at 126 here. For one network, we can connect this many number of systems. But when you come to class B, the network has increased. As the network increase here, the number of hosts per network decreases here. You can see in class B how many hosts you are able to connect here. only 65,534 hosts. Right? Now, let us do for calculation of class B here. Calculation for class C. When you go for calculation for class C here, you can see it here. The number of networks, blindly insert the formulas, insert the values in the formulas here. To the power of like your n minus p, that is 2 to the power of what the n value is 24 minus 3, that is like a 2 to the power of 21. So when you go for 2 to the power of 21 here, how many networks can you create here? 2 to the power of 21 means it's like this, 20, 97, 20, 97, 154 networks. 2097, 154 networks. And the second one is the number of hosts. The number of hosts is 2 to the power of like your h minus 2. To the power of h minus 2. What the value of to the power of h minus 2 will be here? Like a 2 to the power of 8. What the value of h in class C? The value of h in class C is 8 here, to the power of h here, and minus 2. When you go for minus 2 here, that is 256 minus 2, that is your 254 hosts. You can see it here. We can connect more number of hosts in class A, medium in class B, and low in class C. So in small companies here, your class C networks are used here. Medium companies, class B is used here, and in very large here, the class A is here. Okay, you can see it here. A class A is used for your very large companies. The next, class B is used. Class B is used for a medium companies, and class C is used for uh, small to medium companies. The class C is used for small to medium companies. So like this, we have different kinds of classes here. We have class A, B, and C here, right? Now, by using the above formula, based on the above discussion, you should come to one conclusion that, for example, if you're using a class C address, in class C address, how many host systems can you connect here? So in class C address, we can connect approximately 256 hosts. In class C address, we can connect approximately 256 hosts are there. You can see it here. The number of hosts that can be created in class is 256 here, but out of 256 is subtracted with minus 2. How many are valid? Only 254 hosts are valid. Only 254 hosts are valid here. Okay. Now what the purpose here, where they are used here, and how they are used here. Let me design one small network to you here. Based on that, we'll come to discussion here. See here, the small company here, the small company which uh, consists of which consists of four departments. The four departments are, like for example here, like your sales department. Second one is your marketing department, and the third one is your admin department, and fourth one is your finance department. The four departments, and each department they have allocated, and in each department they have 25 pieces here. How many pieces are there? 25 pieces. For sales department here, we have 25 pieces, and for marketing department also we have 25 pieces, and for admin department also we have 25 pieces, and for finance department also we have like a 25 pieces. So each department has Each department has there are a whole number of pieces here. So sales has 25 systems, marketing has 25 systems, admin has 25 systems, and in a similar way finance has 25 systems. Finance has 25 systems. Now what they said means here is, my boss said to assign IP address to all these systems. My boss said assign IP address to all these systems here. Okay. And to assign all these systems here, he has specified one network ID 192.168.1.0. This is called network ID. Actually, what is network ID here? What is network ID? The network ID is nothing but identification of a network. Identification of a network here. For example, take this address here, like 192.168.1. Like a 50. For this system IP, for this IP address here, what is network ID and what is broadcast ID? What is network ID and what is broadcast ID? So I need to identify what is network ID and what is broadcast ID for the system address is. Okay. Now here for the class C's, what the class of IP address is? The class of IP address is class C here. First identify the class of IP address class C. What the octet format is? N dot N dot N dot N dot N dot H. This is octet format. In this octet format here, if we specify H is equal to 0, that becomes network ID here. Right? Now if we substitute H is equal to 0, and that becomes network ID. And if we substitute here H is equal to 255, that becomes broadcast ID. Right? Network ID. This NID is called as your network ID, and this BID is called as your broadcast ID. Network ID and broadcast ID. Now for this address here, what is network ID and broadcast ID? I will write the network ID at the top and broadcast at the top here. For example, the first one is like 192.168.1. You can see it here. This is network. The fourth one is host here. Simply what is saying that simply substitute H is equal to 0 here. That is your network ID. That is network ID. And for this one here, the next one is nothing but a broadcast ID here. So what the broadcast ID is, like a 192.168. Like a 1.255. This is broadcast ID. So for any given address here, if you substitute H is equal to 0, that becomes network ID, right? And if you substitute H is equal to 255, that becomes the broadcast ID. For example, see this one here. Second example, 169.254.3.200. It's class B. What address is class B? What the octet format is? The octet format is N dot N dot N dot N dot N N dot N dot H. N is network and H is equal to host here. Now, so for this 169.224 here, this one, what is network ID? Oh, sorry, this is H. What is network ID and broadcast ID here? So what is network ID is? Simply substitute H is equal to 0 here. So the first one is network, no need to substitute 169. Second one is network, no need to substitute. And what the third and fourth one is? Third and fourth one is host octets here. Simply substitute H dot 0.0 here. This is nothing but your network ID here. And a similar way here, when you go for here, this one here, 169.254.255.255, and what this will be broadcast ID. Network ID is nothing but identification of a network. For example, here in this network ID 192.168.1.0 here, right? So in the 0 here we have a value of H here. He has number of network bits. One number of network bits is 8. We can connect 256 systems. We can connect 256 systems here. So for all these 256 systems, it will act as the identification. It acts as the identification. In a similar way here, with this one here, for all these systems here, this acts as an identification. Network ID means the identification of a network here, right? Now you can see it here, like based on this one here, take an example of this one here, 192.168.1.0 here, the last one is H here, the one is H here, n.n.h here. What is H means? The number of host bits. How many host bits do you have in class C? It is the formula, to the power of H minus 2 here. So what the to the value of to the power of H is? 256 systems here. How many is 256? So for all these 256 systems, this is the identification number. So you can see it here. Based on this example here, we can see that how many systems they have provided to me here. They provided to me with they provided with me with 25 systems here, like 100 systems here. To all these 100 systems, I need to assign an IP address, and the network ID is given is 192.168.1.0 here. Right, network ID. Right, means it's an identification for the addresses from 192.168.1.1 and to 192.168.1.254. 255 కాదు, 255 మళ్ళీ బ్రాడ్కాస్ట్ ఐడి. సో 1 నుంచి 192.168.1 నుంచి 1.1 నుంచి 1.254కి ఇది క్లాస్ క్రియేటర్ లాంటిది అనమాట. అంటే ఐడెంటిఫికేషన్, మొత్తం నెట్వర్క్ ఐడెంటిఫికేషన్. ఫర్ ఎగ్జాంపుల్ మనం ఇక్కడ ఇంకొక నెట్వర్క్ తీసుకుందాం, లైక్ 192.168.2.0 తీసుకుందాం అనుకోండి. అప్పుడు ఏంటి? ఇట్స్ అన్ ఐడెంటిఫికేషన్ నెంబర్, ఇట్స్ అన్ ఐడెంటిఫికేషన్ అడ్రస్ ఫ్రమ్ 192.168.2.1 నుంచి to like 192.168.2.254 వరకు. ఏంటి నుంచి 1 నుంచి 254 వరకు ఎందుకు రాశాను? పైన కూడా అంతే రాశాను, కింద కూడా అంతే రాశాను. వై హావ్ రిటర్న్ సచ్ ఎ మెయిన్ సిరీస్? Like because in class C for one network, how many systems can you connect here? We can connect only 256 systems here. Out of these 256 systems here, we cannot use the first and the last one. అంటే 0 వాడలేము, 255 వాడలేము. 0 255 తీసేస్తే ఇంకేమున్నాయి? 1 నుంచి 254 వరకు ఉన్నాయి కదా. ఆ 1 నుంచి 254 వరకు అవన్నీ ఏంటంటే all those are nothing but valid addresses అన్నమాట. So all those are valid addresses. Okay. Now ఈ బేస్డ్ ఆన్ దిస్ వన్, ఈ సిస్టమ్స్ కి ఇక్కడ 100 సిస్టమ్స్ ఉన్నాయి, ఈచ్ డిపార్ట్మెంట్ 25 సిస్టమ్స్ ఉన్నాయి. అన్ని డిపార్ట్మెంట్ కి ఐపీ అడ్రస్ పెట్టమని ఒక నెట్వర్క్ ఐడి ఇచ్చారు. ఏమి ఇచ్చారు? 192.168.1.0. ఇప్పుడు అడ్రస్ పెట్టమన్నారు. సో అది అసైన్ లైక్ దిస్. లైక్ సేల్స్ డిపార్ట్మెంట్ కి ఏం చేస్తా అంటే 192.168.1.1 టు లైక్ 192.168.1.25 వరకు పెడతా. So I'm assigning IP address from 1.1 to 1.25 for sales here. And then for marketing here, I'll assign like this, like 192.168.1.26 to like your 192.168.1.50. Then for like your admin, for this admin here, I'm assigning like this one, 192.168.1.51 to 192.168.1.75. Then financier, and for financier, like 192.168.1.76 to like 192.168.1.100. So sales ki 1 నుంచి 25 పెట్టాం, మార్కెటింగ్ కి 26 to 50 పెట్టాం, admin ki 51 to 75 పెట్టాం, finance ki 76 to 100 పెట్టాం. So we have sent 100 IPs to all the 100 systems. The job is done. Done. ఇంతకీ నెట్వర్క్ ఐడి ఎంత ఇచ్చారు? 1.0. 1.0 మనకి ఎన్ని సిస్టమ్స్ కనెక్ట్ చేయొచ్చు? 1 నుంచి 254 వరకు. మనకంటే మనకి 254 వ్యాలిడ్ అడ్రస్లు ఉన్నాయి, కానీ ఈ 254 వ్యాలిడ్ అడ్రస్ లో ఎన్ని పెట్టాం? 100 పెట్టాం. ఫైన్, వెరీ గుడ్. They can communicate with each other very smoothly. They can communicate with each other very smoothly. అంత బానే ఉంది, రైట్? కానీ And for all the system address here, for all these pieces, here, one common point is what the class of IP address is? Class C. See, for all the above pieces, the subnet mask is 235.235.235.0. Subnet mask is 235.235.0 here. Means all the systems can communicate with each other. All the systems can communicate with each other. Any communicate होते हैं? Yes. Any department, sales department can communicate with marketing department communicate with the admin department, and admin department can communicate with finance department. So every department can communicate with each other. So all the departments one department communicate with other departments. So all the departments can communicate with each other here. Now, one day the boss came to me and say that here, boss, one department should not communicate with other department. See, all on the same network, 192.168.1, the network ID. The network ID is same for everyone here. So that's why everyone can communicate with each other here. Suddenly one day my boss said here, boss, one department should not communicate with other departments. Then what to do? One department should not communicate with other department. So if you want one department to not communicate with other department here, just 1 minute. Now, if you don't want one department to communicate with other department, yeah, then you can do one thing. Like for sales, I give this 192.168.1.1 like 192.168.1.25. Okay. The next for marketing here, what it will give here is 192.168.2.12 like your 192.168.2.25. Now tell me, can the sales communicate with marketing? No. Why? The sales network is different and the marketing network is different. That belongs to two different networks. They cannot communicate with each other. Now you can see it here, like for like your admin, what is say that here, like 192.168.3.1, 3.1 and to 192.168.3.25. Then your finance here, when you go for finance here, like 192.168.4.1 to like 192.168.4.25. So what do you mean by this? One network cannot communicate with the network. Sales cannot communicate with marketing. Marketing cannot communicate with admin. Admin cannot communicate with finance. Why? Because all are in different networks. All are in different networks. They cannot communicate with each other here. But if you want to enable sub, if you want, but the thing is, but the boss said that don't change the network, be in the same network and establish the security between the networks, and that is one department should not communicate with other department, then what to do? Okay, one department should not communicate with other departments. If one department should not able to communicate with other department, then what to do? Okay, so for this one here, we use this concept that is called as subnetting. The concept is called as subnetting. What is subnetting means? Dividing a single network into multiple independent networks. Multiple independent networks is called subnetting. Dividing a single network into multiple independent networks is called as subnetting. But it's very bit complicated here. It requires a lot of calculations here. If you go for all the calculations within a single day, you'll get confused here. We'll discuss this subnetting tomorrow. Hello? Can you, any of you come to online, please?
Okay. Yes.
Naina, ekkinda?
Yeah. Okay.
ఏమో ఒకసారి రిఫర్ దిస్ ఫర్ 1 or 2 times. It's very bit complicated here, very bit చాలా complicated concept ఇది, and read this for 1 or 2 times. If you're not able to get it here, ask me, I'll explain it for one more time.
Okay.
ఒకసారి explain చేస్తాను, and when you are clear about this one, then we'll go for subnetting. Okay. Right, so I'll stop you for today, and we'll meet as usual tomorrow at the same time. Okay.
Okay.
Right, thank you.